do you guys say? Let's get some ice cream. Oh, well, we're setting up the next problem. Think about what your favorite ice cream place is in Valpo. Is it Valpo Velvet? Is it Pat's Ice Cream Parlor downtown? Are you a Cold Stone junkie? You go and spend, $8 on an ice cream, but I'll tell you, it's the best ice cream you'll ever have. Or are you just like a Dairy Queen kind of guy, kind of gal? What's your favorite? You should all email me. You know what? When you submit your homework, by midnight, put in the subject line what your favorite ice cream is. That'd be fun. That'd be fun. All right, draw a cone, everybody. Starts out by drawing a triangle, and then that's a cone. Doesn't get any easier. Get the center of that circle. I'd like you to go all the way up to the very, very top. Let's get my ruler out. It's kind of slanted, sorry. Should be perpendicular to the base. It really doesn't look perpendicular to the base, but that's your height. That's your height. From here to here, that's your radius. It's the radius of the bottom circle. By the way, the circle of a cone is a base. I guess we can put base here. But the base of every cone is a circle. I'll say that again, sort of important. The base of every cone is a circle. Whereas the base of a pyramid can change. It could be a square, it could be a hexagon. The base of a cone is always a circle. All right, radius, height, base. This is the vertex up here. And just like what we had on pyramids, when you go from the top vertex, come all the way down, that's your slant height. I'm going to write that in. Super important. This is your slant height. That's your height. That's your slant height. That's the height of the pyramid. That's the slant height of, or not the pyramid. That's the height of the cone. That's the slant height of the cone. And that's really all you need, folks. I'm going to give you the equations. Here we go. The lateral area, meaning if you were to take a cone and kind of paint this outside surface all the way up to the very top and behind as well, if you can visualize. I wish I had a 3D model to kind of show you, but if you painted that curved surface of a cone, the lateral area is pi RL. Pi times the radius times the slant height. Surface area. Well, it's going to be the lateral area. It's going to be that blue curved surface plus a base, which is a circle, a yellow circle. So a little more, technical formula looks like this. Surface area is going to be lateral area, which is pi RL. I just gave that to you right above. You can substitute, plug it in, pi RL plus the area of a circle. What's the area of a circle, folks? It's the most famous equation in all geometry. It's pi r squared. That's the surface area of a cone. Example 3. Here we go, folks. We're rolling. We're rolling. A cone has an altitude of 8 inches and a diameter of 2.5 inches. I'd like you to find the LA and SA. A cone has an altitude of 8 inches and a diameter of 2.5 inches. Find the lateral area and surface area. And just to be different, we're going to draw a picture on this one, but let's draw an upside down cone. Let's put the point at the very bottom. Let's do this, folks. Okay. Center. An altitude of 8 inches. That's the same thing as a height. Altitude, height, altitude, same thing. So a height of 8 inches. Cool. 8 inches. What else do they give us? What else do they give us? They give us a diameter of 2.5 inches. So if the diameter is, it's completely across the circle, I don't really want to work with the diameter. I want to work with the radius. So if the diameter is 2.5, then the radius must be half of that. Mental math, $2.50 cut in half is $1.25. So the radius is 1.25 inches. Okay. That's all they give us in the problem. Is that enough information to find the LA and the SA? I think so. Lateral area. Let's go to the equation. What is it? Pi RL. Pi RL. Okay, pi radius. What is a radius? It's not 2.5 diameter, Mr. Kosal. Radius is 1.25 times the slant height. I think I should just no. Do not put 8 right here. That's the height. Slant height is right here, and that should have been a right angle. They'll have that in the book. Mr. Kosal likes to forget that from time to time. To find the slant height, once again, Pythagorean theorem, 1.25 squared plus 8 squared equals x squared. Here's your x. It's the hypotenuse. It's across. It's across from the right angle, which means it's the longest side. Okay, 1.25 squared, huh? Is that number, folks. 1.5625 plus 64 equals x squared. X squared equals, you really don't even need a calculator for this. How about 65.5625? And then square root that number. 65.5625 square root, bam. X equals, so square root both sides. X equals 8 point, what do you want to say, 1? 8.1. Cool, 8.1. Everybody, 8.1. 8.1. But, we're going to punch this out in the calculator anyways to find the lateral area. Why not just keep this in the calculator? Because this is the exact answer. This is a rounded answer. Keep this in your calculator and multiply it by the 1.5, or 1.25, excuse me, equals, and now multiply it by pi. All right, there's your lateral area, folks. If you painted the curved surface of the cone, this is what you're going to get. 31.8, rounding, inches squared. Surface area, you're on your own. If you need to watch me, watch me. If you don't, you don't even need to look at the computer, folks. Plus pi radius. What is a radius? 1.25. Okay. 1.25. Oh, no. 1.25 squared. Where's the squared button? There it is. Okay, square times pi. Okay, so that is 4.9. Okay, let's round it. And then surface area. That's the lateral area plus the bottom. Hopefully I did this right. But add that 4.9 plus the 31.8, and you get a surface area of 36.7 inches squared. All right, folks, your homework. That's it. That's all I got for you. I'm going to write the homework over here. It's a bunch of sporadic problems today. So it's on page 859. 1, 2, 5, 6, 7, 8. I guess I could have said 5 through 8, right? 1, 2, 5, 6, 7, 8, 11, 14, 15, and 55. Midnight as always, folks. Have a great Friday. Have a great weekend. We'll see you on Monday. Adios.